For this video, I want to talk to you about properties of exponents. I wrote them out in my own words just to make them a little bit easier to understand. So the first rule is if you're multiplying values with the same base, what you're going to do is add exponents. So for example, if I have x squared times x cubed, I would take the exponents and add them together, and I have a total of 5 x's that I'm multiplying together. The reason why we add them together is because x squared, remember, is x times x. And then if you take the x cubed, you really have 3 more. So if you count, you have a total of 5 x's, which is why we add them together. All right, our next rule tells us that if we are dividing values with the same base, we're going to subtract the smaller exponent from the larger and write the answer in the location of the larger. A lot of textbooks will tell you to do this with just subtracting the exponents, and it doesn't say to move only the smaller one, and then sometimes you end up with a negative exponent and then you have to move it down. I just find it's easier to keep the larger one where it is and subtract the smaller from the larger. So for example, if I have x to the 4th divided by x squared, I can write this as x to the 4th minus 2, which ends up being x squared. So again, it's always important to kind of understand why this works the way that it does. The reason this works is on the top I have x times x times x times x. And then on the bottom I have x times x. So we can see that there's 2 of them that we can cancel out. And we're left with 2 on the top. So that's why we subtract the exponents. All right, another one, just so that you can see what happens if it's in the denominator, is the larger one. If I have x cubed over x to the 7th, the cubed is smaller, so it makes more sense to do 7 minus 3 because that will give me a positive value. So I would write this 7 minus 3 in the denominator. I still have to have something in the numerator since there is a denominator, so I just put a 1 up here because that's what we would be left with. So I would end up with 1 over x to the 4th, and that would be my final answer. Again, the reason it works this way is because I have 3 x's on the top that I could cancel with 3 of the 7 x's on the bottom, and if I take 3 away from 7, I'm left with 4. And then our last rule that we often use with exponents is the power rule. So this happens if I have a power. Let's say, for example, that we have x to the 4th, and I square it. What I'm going to do is I'm going to multiply the 2 exponents. So I have 4 times 2 equals x to the 8th power. Okay, and the reason why this is the way that it is x to the 4th squared really means taking x to the 4th times x to the 4th. So then if we use the rule that we saw earlier, if we add the 2 exponents together, we also could arrive at x to the 8th. I got a little bit excited about writing the 8 there. All right, so just remember that these rules are for exponents only. This does not include any of the values in front or the coefficients. The coefficients just follow the traditional rules. If you're multiplying, you just multiply them. So I did throw some coefficients in so you can see what happens. All right, so we're going to try 3 together, and then I'm going to have you try 2 on your own. So for this one, we have 5a to the 5th times a cubed over 10a to the 6th. So there's a lot of different ways that you could approach this. What I'm going to do is I'm going to simplify the numerator first and then subtract fractions. And I'm just going to ignore the coefficients for a second. So if I simplify this, I would end up with a to the 5 plus 3. Over 10a to the 6th. And a lot of times I would not actually show out the work, but because I'm demonstrating it to you, I want to make sure that you understand where I'm getting the values from. So I would end up with 5a to the 8th over 10a to the 6th. Okay, so now what I'm going to do is I'm going to look at these coefficients here. I'm going to look at the 5 and the 10, and I'm going to pretend the a's aren't there. If I have 5 over 10, this reduces to 1/2. Okay, and then I'm going to look at my exponents and decide which one is smaller. So since a to the 6th is smaller, I'm going to move it to the top by doing a to the 8 minus 6. So my final answer would be a squared over 2. Okay, I don't have to write the coefficient of 1, it's just implied to be there. So I would have a squared divided by 2. All right, moving into the next one. This one also has coefficients. So the coefficients I just treat like normal numbers. So I would just do 3 times 2 times 2. I just treat that as regular multiplication. I could do 2 times 2 instead of writing it this way. I could add the exponents here and do 1 plus 1, which would give me 2 squared, which is the same thing as 2 times 2. So you could apply the same rules of exponents to bases that are numeric as well as bases that are variables. Okay, so now if we look at the x's, we would add the 2 plus the 4 plus the 5. So add the exponents, but multiply the coefficients. So now if we simplify, 3 times 2 gives me 6, times 2 more gives me 12. Or I could have started with the 2 times 2, got 4, 4 times 3 is also 12. So a lot of times there's more than one way to arrive at the same answer. Now if I simplify this, 2 plus 4 gives me 6, plus 5 more gives me a total of 11 x's. And that would be my final answer. For the final one that I'm going to do with you, we're going to take 4x squared to the 3rd power. You do have to distribute this to everything inside, so this does apply to everything. Remember that this is an exponent, so the exponent that's understood to be on the 4 is 1, so I really have 1 times 3, which is just 4 to the 3rd power. Okay, don't ever multiply the exponent by the coefficient. You're only multiplying the exponent by the exponent, so 3 times 1 is just 3. For the x, we would do 2 times 3, and then we would simplify. So 4 to the 3rd power means 4 times 4, which is 16, times 4 more, which gives me 64. And then with my x's, I would just multiply the 2 times 3, which is 6, and that would be my final answer. So what I did was I came up with 2 you try questions for you to try on your own using the rules and different combinations. Go ahead and pause the video, try these 2 and see if you can simplify them, and then once you have tried both of them, resume watching the video and I will go over them. Alright, now that you've had a chance to try these on your own, let's look at the answers. So coefficients, I would multiply them, so I get 2 times 3, which is 6. My x's, I'm going to go ahead and add these together, so I have 3 of them plus 1 more, so that would give me x to the 4th, over x to the 5th. And then I can simplify this further. Since this one is smaller, I'm going to move it down, so I would end up with 6 over x to the 5 minus 4, which just gives me x. And that would be my final answer. So if you got 6 divided by x, then you did it correct. All right, for the last one, you're going to square both values inside. So I really have 3 squared times x squared squared, or x to the 2 times 2, all over x cubed. So now if I simplify, 3 squared gives me 9, x to the 4th, over x cubed, and then I can simplify, and since x cubed is my smaller value, we would subtract the exponents. So when I subtract the 2 exponents, I just end up with x, because 4 minus 3 gives me 1. So hopefully that showed you how to use the rules of exponents. So remember that if you're multiplying, add the exponents. If you're dividing, subtract the exponents. And if you're taking a power to a power or an exponent to another exponent, then you multiply the exponents. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you would like me to cover, please let me know that as well.